Hi, Mr. Boer here for week 5 of remote learning for geology. This week we're going to focus on chapter 10, which is geologic time. A little bit of history on geologic time. One of the things they focus on was the early ideas of geologic time, and the idea that the Earth's history looked at it was an idea known as catastrophism. And basically, that's more of the biblical way to look at um, the geologic history because it was developed by James Ussher in the mid 1600s by looking tried to find out how old the Earth was by looking through biblical references. And basically, he came out with the fact that the Earth was only a few thousand years old, and had been developed landscapes like mountains and valleys and all the features and landscapes you find on the surface of the Earth had been created by these large catastrophes that took place. So they call it catastrophism. Be like the Great Flood and some of these other things that caused mountains and valleys to form. Um, that held its own at least until the 1800s, and we start getting some idea that the modern geology, and they start using what's known as uniformitarianism, which is the idea that the present is the key to the past. In other words, processes that happen on the Earth today are the same processes that happened in the Earth's history. So if we see rivers creating valleys today, we see mountain building, volcanoes, and things creating plate tectonics, creating things happening today. Those are the same processes that happened in the past. So we can use the idea of the past being the key to the present. And that is mostly developed by James Hutton. So there's basically 3 people you're going to have to know in this chapter. Archbishop Ussher, or Ussher, as we just said, was basically the biblical interpretation of the Earth's history, and he used catastrophism. And then there's Charles Lyell and James Hutton, who came up with modern geometry. James Hutton is given most of the credit, but he used a lot of Charles Lyell's ideas. So we kind of need to know both. But James Hutton comes up with uniformitarianism, which is kind of the idea that we still focus on today. And what he was able to do is come up with relative dating techniques. Now, that doesn't mean dating your relatives. It's a sequence of events. There's 2 types of dating that end up geologists use to try and date the Earth. There's relative dating. We use a sequence that this happened before that. If you want to use relatives, you could you are younger than your parents, who are younger than your grandparents. It's a sequence. It's not telling you exactly how old they are, or the spans that took place. We can say this rock was deposited before this rock, so we know it's older. That's using relative dating principles that you will need to know. Or there's absolute time dating, which is using radiometric dating. So we can use isotopes, radiometric isotopes, to determine like carbon-14 dating that we use to find out how old fossils are and things like that. And that's the second part. But if we look at relative dating, we need to know these simple principles to follow to figure out the sequence of events. First one's the law of superposition. Oldest rocks are on the bottom. It's an easy way to say, if I was to give you your homework back every day and you put it at the bottom, you put it in your bottom of your locker, every single day you get it back. And then at the end of the year, I say, hey, I need that assignment I gave you from the beginning of the year. Where are you going to look for? On the bottom, because that was deposited first. And we look at rocks as kind of the same thing. Principle of original horizontality is that when sediments are deposited in a depositional environment, it's almost always water. And it spreads them out so that when the layer of rock is deposited, it's original horizontal for the most part. If it's tilted, something happened to it. Some plate tectonics, some forces, some stresses that we talked about before. The third one on there talks about the principle of cross-cutting relationship. That's usually dealing with igneous material. That in order for a lava segment to come up through, that we had tell you, the dikes and sills and batholiths that we talked about with volcanic features, it had to exist there in order for you to be able to get up through it. If not, the lava comes to the top and it spreads out horizontally. So if it's cutting through something, then we know it's younger. So we use a few of these principles to determine ages. And a lot of this can be done by looking at the Grand Canyon, because we know that the Colorado River cuts through these layers, erosional features. So you end up getting